Hey guys, welcome to today's lesson. This is the second lesson in our sequences and series for the IB Math Studies course. So hopefully if you haven't watched the first introduction, please do so. Gives you a brief introduction about what, first of all, a set is, what is a sequence, and what is a series. So just a quick review of that. A set is just a group of numbers or objects, so 5, 2, 8, etc. The sequence was the set of numbers that has a pattern, so 5, 7, 9. Okay, and a series was the sum of that set. Okay, so 5 plus 7 plus 9 plus dot dot dot. We also looked at what it was an AP. We remember an AP has a common difference, all right, D, and was also sort of known as a linear pattern. Okay, has that common difference. So today what we're looking at is, I guess, more detail about how what the general term of an AP is. So, what's going to happen is, they'll get questions for this one, for example, and they give you a series. They ask you to find the next two terms or the next three terms, which is pretty straightforward. They might even ask to say, is this an AP? Is this an AP? And they might ask you to find the 100th term. So that's generally the most common types of questions, okay, that you might see for this. They do get more difficult, particularly for B, depending on what the question looks like. So to find the first next three terms, well, we can see that the common difference is 2. Add 2, add 2, add 2, so we know it's going to be 11 and 13. So very straightforward. Is this an AP? Well, the AP is, we want to show, I guess, that U2 minus U1 is equal to U3 take away U2. Okay, in other words, 7 take away 5 equals 2. 9 take away 7 equals 2. Therefore, a common difference, so it's an AP. Alright, that's what I mean by showing that it's an AP, is just stating that there is a common difference, and generally speaking, that bit there is perfectly okay to give. Alright, of course, that's a little bit more technical, and certainly those who are looking for your 7s, that's the kind of language that you should be looking at. But then we get to this last question, find the 100th term. So of course, if I'm going to rewrite this, U1, U2, U3, that's what I've started with to begin with, right? And I'm looking in terms of a sequence, not a series. We've got a 5, we've got a 7, we've got a 9. What we're trying to find, dot, 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 is the 100th term. So of course you could be plussing 2 and plussing 2 and plussing 2 all the way up to you've plussed it 100 times or you get to the 100th term. But we want a quicker way. So first of all, what I'm going to look at is, well, that first term, yes, it was 5. That second term was 5. But then we added 2 to it. The third term was 5. So the second term was 5 plus 2. But then we added another 2 to it. What will be the fourth term, U4, do you reckon? Well, we'd have the 5 plus 2 plus 2. But then we'd add the extra 2 together. Now, of course, you don't need to really know how to get to this, but I want to show you because I think it's quite interesting and can be quite helpful. The one common thing in all of these terms is they all start with that first term of 5. Now we know that to be U1, right? So what we're going to do is come up with UN, because in theory that's what we're trying to find, right? U100 or U50 or U30. And each of these terms we know starts with a 5, which is the first term of U1. There's a plus in all of them, but then we start looking at this common difference. We don't have one in the first term. We have one of them in the second term. We have 2 of them in the third term. We have 3 of them in the fourth term. Can you kind of see what's going on? If I've got the 100th, we're going to have 99 of them. That's because whatever term we have, we subtract 1, and that's how many times we have a difference. And there is the birth, I guess if you want to call it, of the formula for the general term of any AP. Alright, remembering that the AP is a linear pattern that has a common difference. You are given this rule in the formula sheet, but it is a good idea to try and learn that formula off by heart. Okay, so let's have a look at another example. EG2. We're going to look at, let's say, 8. We'll look at 12. Look at 16, dot, dot, dot. So the first question I'm going to ask is I'm going to say to show it's an AP. I'm going to ask you to find the general term of the AP, and I'm going to ask you to find the 100th term. If you want to pause it, have a crack at that question and come back. Okay, so how'd you go? Now, first of all, we want to show that this is an AP. All right, we know it's an AP if there is a common difference. It's the first thing that goes through my mind when I see the word AP. So straight away, I look at this and say, okay, well, I got plus 4 and I got plus 4. How did I get that? Well, I got that by saying 12 take away 8 equals 4. I also got that by saying 16 take away 12 is 4. Therefore, there's a common difference. It is an AP. Okay, if you want to go ahead and be technical and say T2 take away T1 is equal to T3 take away T2. I'm taking these T's here. I shouldn't be using T's. I apologise. That's HSC language. U2 minus U1 equals U3 take away U2. That is our common difference, all right? That's what our D is going to be. So I've done that. I've proved there's a common difference. Find the general term of the AP. Well, straight away I'm going to use my IB language. UN is equal to, well, U1, that's my first term. That's 8. Plus n minus 1 times that common difference we found of 4. And that would be satisfactory. If you want to go ahead and say 8 plus 4n minus 4 equals 4 plus 4n or 4n plus 4, you could go and do that. Okay, but to be honest, that's what I like to see. I don't really want to care about you going more forward than that. But you can if you wish. And the great thing is, once you've got that, that last question's really easy because U100 is equal to 8 plus 100 minus 1 times 4. And I simply put it in. You could also put it into this formula here and say 4 plus 4 times 100 minus 1. That also works. So we've got, what's that, 99 times 4, so that's going to be 4 less than 400, so 396. So 396 plus 8, which equals 404. Hopefully my maths is correct. Okay, so that's the 3 questions they're going to ask, right? And they don't change too much. The only question I want to show you, and then we're going to finish up on this because that's really all there is, they do get 2 slightly harder questions, all right? And they do get them. So, the first harder one, they give you something like this. There might be x plus 2. There might be x. Actually, I'm going to make it 3x plus 1. And then I'm going to make it 5 outside of x plus 2 on 2. Now, they might say that this is an AP. Find values of x. Okay, so this is a typical challenging question, right? You're told that it's an AP, and without being told it's an AP, you're not going to be able to do it because if it's a GP, it's going to be done a different way. So what do we know about an AP? We know that there is a common difference. All right, we've already looked at that. We know that D will be equal to U2 take away U1, which is also equal to U3 take away U2. So what we're actually doing here is we're going to be forming a linear equation. So I'm going to start with this one. 3x plus 1 take away x plus 2. I'm going to put them all in brackets actually. And that's going to be equal to U3, which is 5 outside of x plus 2 on 2, take away 3x plus 1. Okay, I form my equation. Now, of course, those negatives are important because we're taking away the whole thing, all right? And that's just if I had that 3, 5, and 7. You're doing 5 take away 3 is equal to 7 take away 5. It's just an equation, albeit challenging. Now, because you've got your GDCs, your graphics display calculators, you can literally type that in left to right into the F3 solver. All right, and I'd probably, at this time, I'd probably encourage you to do that. Because what we now need to do, if we don't have that calculator, is we're expanding our brackets as such. All right, and then we're getting everything to a common side, or let's say we want to get the x's all to the right hand side, and so left hand side, the numbers to the right. You know, I'm taking the +1, I'm minusing 1, taking the -2, I'm plussing 2, I'm taking the -3x, and I'm plussing 3x. I can't touch that right now, so I'm not going to touch that. That gets me, so 3x plus 3x is 6x, 6x minus x is 5x. I get this 5x plus 10 on 2. Then I've got -1, -1, it's -2. -2 plus 2 is 0. Okay, that works out quite nicely. I can get rid of the divide by 2 now by timesing by 2. I get 10x equals 5x plus 10. I can take the 5x across here by minusing it. I'm left with 5x equals 10. I'm left with x equals 2. Bang! My solution. But that's pretty challenging, right? And if you just use your GDC up here, you literally could have plugged that straight in left to right in your F3 solver. Press solve, get x equals 2, and you move on. So that's one type of question you can be asked. It's pretty challenging, right? Hence why it's, you know, it's not easy. The last type I want to throw at you is something like this. They give you, let's say, 5 and 8 and 11, ... All right. And they might say, find the first term above 120. Now you could sit there and go, okay, I'm plussing 3, I'm going to plus 3 all those times, but you need a bit of working out and you need to save a little bit of time. So this question, what we're looking at, the first thing I see it's an AP, right? We know it's an AP because the D equals 8 take away 5, which is equal to 11 take away 8, which is equal to 3. I also know that if I want to find UN, the first term is 5 plus n minus 1 times 3. We get that as well. But this bit is saying, well, when is UN greater than 120? When is it bigger than 120? So what I can now do, I can chuck some of these together. This is my equation, albeit I don't know what n is, and I can throw it in here in terms of substitution. 5 plus n minus 1 times 3, and we're creating that inequality. 5 plus 3n minus 3 is greater than 120. 5 take away 3 is 2, plus 3n is greater than 120. 3n is greater than, take away the 2, 118. N is greater than, well, 3 into 11 goes 3 times with 2 left over. 328 goes 8 times, goes 9, 3 to 27, so it goes 9 times 1 left over. Of course, you chuck in your calculator and you get a much quicker answer. But it has to be greater than 39 1/3, which means because n must be an element of a positive integer. It's got to be, right? It's got to be a counting number, kind of. It's got to be n, u1, u2, u3, u4. You can't have a 4.5 term. So, in this case, n is equal to 40, which means my 40th term will be above 120. The problem is, that's not what the question asked. The question said, what is the term? So I now go and put it back in and say, well, u40 is equal to 5 plus 40 take away 1 times 3 equals 5 plus 39 times 3. Okay, which equals 5 plus 117, which equals 122. Okay, 122. It's a bit hard to see, I apologise. It's there. 122. Use the other one. Still a bit light. So you can see that's a pretty tough question, right? But it's knowing the things, like it's an AP. So if I know the AP, I know that formula. I know there's a common difference. What can I do with that information to create my kind of equation? All right, that's a pretty tough question, guys. So those last two, you need a bit of work on, but hopefully, as I said, out of this lesson, what I want you to understand and what I want you to get out of it is refreshing the whole idea of what is that AP. We know that AP has a common difference. Okay, we also know that means that D equals U2 minus U1, which is equals to U3 minus U2. And we also know that to get the nth term, we've got the first term plus n minus 1 times that common difference on our formula sheet, but we should learn it. Hope it made sense. Hope it was useful. The next session we're going to be looking at the sum of an AP or a sum of an arithmetic series. Have a nice day.